Hello.
All right, guys, we're going to get started. Good afternoon. My name is Chris Caruso. I'm with the Brainshark team out of Boston. We're a learning platform that's used by over half the Fortune 100 companies to provide training and coaching to their sales teams. Today at Build, our Brainshark Labs team is showing our latest app, which we've built in partnership with Object Theory. Check them out right in front of me in the white aquarium. They're awesome. Our HoloLens app is combined with Microsoft Cognitive Services to provide a next-generation sales training experience for users. I'm joined by Michael Ferrioli and Dan Coakley, and we're really excited to be here. Michael, let's get started.
Thanks, Chris. So, we were here last year, and that keynote that Satya did last year, where he really focused on cognitive services, really sent us in a direction that Brainshark never thought we would go down. Like Chris said, we're in the business of making salespeople better at what they do. We do that through an online curriculum, finished up by a coaching challenge. And the way that works is that you take your courses. When you're done, you prove to your manager or your reviewer that you've mastered the message and the content, stare into a webcam, and deliver that message. Your boss then has the ability to decide whether you're ready to go actually sell that product to customers. So, it's working great. We have Lenovo, Cisco, NetApp, a lot of Fortune 100 companies are using it. They love it, but we wanted to make it even better. So, how can we take some of those cool Microsoft advanced services that we heard about this morning and last year at Build and weave them into our current product to make it a truly next generation product? So first, we thought, well, online learning is great, right? Courses, we've all done online courses, but are you really ready to deliver that message into a webcam after taking some online courses? Second, does the sales manager, these are really busy people. Do they have time to sit through all those videos? And what we've noticed in our product is they're not always honest, right? It turns out people don't actually like to criticize other people, but they will accept criticism from machines. So we built two separate but related products. First, we built a HoloLens-based sales simulator. What this allows the salesperson to do is get inside a real-world selling situation and make the mistakes there before they get in front of a real customer. All right, we've wired it up to back-end services, cognitive services, Lewis and Chris, you heard about this morning, so that if you're using custom jargon, we can actually provide a custom speech engine to recognize your product names, company names, and so forth. So this really is where the salesperson goes to make his mistakes, and frankly, it's actually quite terrifying. We also built, thinking about the sales manager, we built something to save him time as well. So again, coming back to Azure-based cognitive services, how can we take a raw video, extract the text, do face emotion detection, and all kinds of other analytics on that video to decide, is this person convincing? Are they persuasive? Are they ready? All right, who wants to see the sales simulator?
Fire this guy up here.
Not getting the sound.
There's no sound.
All right, so we're having a little problem with the sound back there, but let me just stop here and sort of
Start it again?
Yeah.
show what you're seeing.
No.
So, gotta love a live demo. So, all right, go ahead. Try it again.
Take two.
Welcome to the Brainshark Sales
There we go.
Simulator. Please say your 5-digit challenge ID to get started.
What did you do?
85012.
Hello, Chris. You have been invited to participate in a sales readiness challenge for Healthy Lunch. When you are ready to start the challenge, say, I'm ready.
I'm ready.
See what I mean by terrifying? That countdown will really get your heart rate going. So let me stop Chris for a second and just sort of explain what you're seeing. So up in the upper left, you have a heads-up display which shows all of the topics that Chris needs to hit, right? So part of being a good salesperson is how you project yourself. Just as important as making sure you communicate all of the points in the message. So we're doing real-time speech-to-text conversion to make sure that Chris actually hits all of his points. We also have the PowerPoint slide deck. We're measuring his heart rate using a Microsoft Band, obviously a timer, and most importantly, we have the three, in this case, very skeptical prospects that Chris is pitching to. Notice that there's an engagement level on all of them, and that should change. So you might see some interesting things happen. So take it away, Chris.
Good afternoon. Thank you for speaking with me today. My name is Chris Caruso, and I'm an account executive at Healthy Lunch. Our company was formed with the simple idea that eating healthy, God bless you. Our company was formed with the simple idea that eating healthy leads to more productive employees, which helps with our output. Here's how it works. Your company subsidizes the program on behalf of your employees, allowing them to make healthier, smart.
Tell us more about how you work with local vendors?
Oh, you're right, I missed that. We work with local vendors to create healthy nutritional menu options available at an affordable price to our employees. Jason, I noticed that I'm losing you there a little bit. We also offer in-house menus as well as dine-out services, and we'll soon offer in-house catering. Thank you. Are there any questions? End simulation.
Great job, Chris. You've completed the Sales Readiness Challenge. Please review your performance summary.
Hey.
If you'd like to, wonderful. I'll submit your results.
End simulation.
See you again soon, Chris.
All right. Give a hand for Chris. So you saw there that that Jason was losing his attention because Chris wasn't saying his name. It also works with the HoloLens gaze capability. We're really working on adding all kinds of new interactive ways so that every time the salesperson gets in the simulator, they don't know what to expect. The goal is to let them make their mistakes inside the simulator. All right, so let's look at the video analytics and machine scoring that we did. Can you scroll up? So as in any good live demo, the video isn't working. So this actually is all delivered from Azure Media Services. I'm sure Azure is not down, but certainly the internet in the space is. So what you would have seen is a video that Chris, once he's out of the simulator, right, and I'll sort of take on the persona now of Chris's manager, which I like to do because he's actually my manager. And now I'm going to review his final coaching video. What you would see during the videos, you would see sentiment graphed on the left in real time and graphed over time on the right. You see that we've converted all the speech to text in the bottom, and you can navigate through the video that way. We're doing some lexical analysis on what Chris was saying, and above that, sorry, you would have seen the facial emotions, right? We sample that every quarter of a second, and we graph it every second. Down in the lower right, we learn a little bit about Chris as a person. We can either do that just based on this coaching submission or on all coaching submissions over time. We have the topic coverage, so in this case, Chris got 100% coverage because he spent a lot of time in the simulator. We have a word cloud because who doesn't like a word cloud? And then lastly, we have the machine score. That machine score was actually built using Azure ML Studio that we operationalized into a REST endpoint, and we can now shoot videos into, and it will machine score. So the goal here is to make it so that the sales manager doesn't need to spend time reviewing all these videos. All right, back to the PowerPoint. All right, so I'm going to turn it over to Dan Coakley, who's going to take you through the architecture of how we built the machine scoring piece, and we're going to go deep dive into code.
All right. Hello, hello, hello. Hello? Hello. Hey, there we go. All right, cool. So that demo was awesome, and I want to spend the rest of the time to basically just walk through sort of the high-level architecture and then dig into some of the specific areas of code we use to actually build this out. So this starting off is really just a reference architecture of the entire piece for the cognitive services portion. So this is everything that says, okay, he's uploaded a video. How do we generate all the analytics, all the metrics, and then finally the machine score to render that page that we just saw? And normally we have the video and some extra stuff, but we'll assume that works. So really the first part on that top line is the processing. So we have an MP4. It's really what cognitive services and what Azure services and even external services can we call to just generate raw data about that video. And so the centerpiece of that is the Azure Media Services. And so we're generating both the emotion JSON as well as the speech to text. And we have Azure functions that sit on either side of that and basically control that operation. And then we move on to the next phase in the middle, which is really, now we have all of this raw data, how do we process it and then store it into the document DB, which is where we keep all of the data. And then we have basically the render and then the score. So how do we just get back the pieces of data that we just processed through to display on the web page? And then more importantly, how can we actually connect that data into Azure ML Studio or any machine learning workspace and try to pull that data in and try to extract some more information about it? So I'm going to start first after I switch back to the computer, which will definitely work. Aha. I'm going to start first with the Azure functions. So as we saw, that incoming message is triggered off of a service bus queue, and this is inside the Azure portal. We have two functions. One's called this BSK Advanced Analytics Processor, and then this other one is just a status. So this first one, the Advanced Analytics Processor, is triggered on the service bus queue message. So anytime we have a video that we've uploaded into AMS, we just drop in the asset ID, and this function is going to trigger. So let's take a look at what this is actually doing. So I'm sure those master keys can't be that important, so I'm going to close those. Go away. Okay. So the first thing we can actually see, we're using regular libraries that are provided by Microsoft, and the way we're able to do that is through the project.json file in here. And so we can define our dependencies. And so here we're actually saying we want to use the libraries that already exist for C# to interact with Azure Media Services, blob storage. You have access to pretty much anything off of NuGet.org, and you can pull it right down into the function itself. So that means really inside of here, we get this run, which is essentially the main method. And this BSKML message is going to be our message off the service bus trigger. And then we have an out, which is another queue that we're not actually using it, but if you were writing a message out to something else after this, you could write it out through this variable. And so really the heart of this is going to be this submit face detection message. So this defines the two JSON configs that we're going to submit to AMS. And so this is the one for the emotion, and it says take 250 millisecond averages of the emotion displayed by the people on the screen, and then run that every second. And it's going to run through the entire video and build up that JSON. The second one, we're going to say generate the speech to text. And so that's going to generate this web VTT and TTML, which are just sort of standard speech to text formats for the audio, or sorry, for the text. So then we're going to connect to our Azure Media Service instance. We're going to tell it, as it's processing, we want it to write notifications out to another queue. So this is how we're able to disconnect and have one function just submit messages, just fire and forget, and have another Azure function on the other side picking up the status as that's happening so that we can act on it. So that way nothing's waiting on the wire. Some of these big videos, it might take 2 hours for that to finish running. So this way, this fires and it's done, and then there's nothing kind of waiting or taking up resources. So the core of it is this job, and then from the job we can chain tasks. So we're going to say make an emotion task, which runs that JSON we just had. Do another one, which is the index task, which is the speech to text, and then we just submit it. So here in essentially 100 lines, probably less if you could write code a little better than I did. So you can take a video, you can generate the emotion expressed by every person on the screen, and you can get a full transcription in essentially 100 lines of code. So then if we flip to the other side, the status function, I'm going to scroll up, is really doing even less. This one is taking messages from AMS, and then it's saying it's looking for essentially when the notification type is job finished, and then it's getting all the IDs for those videos, and then it's passing that on to another web job. So if I flip back to our reference architecture, whoops, by way of the HoloLens. So we can see we're on the other side of the Azure Media Analytics, and now we're at the web job. So the point of this is really to just go through and process that video that we just saw, and it's going to trigger on that output from the function, and it's going to say, okay, I have this document DB, and I have all of this data that I just generated. How can I go through and basically parse it out and insert it in a usable way? And so I'm going to show you, this is the format of a web VTT file. So there's really a start time, an end time, and then all the text you set in between. And so what we can do is basically break these down into records. So we have a start, an end, and then using this web job, we can find out what the average emotion was over that time period. And we can also call out to other cognitive services like sentiment analysis and say, well, what emotions or what was the positivity or negativity of what the person was saying? And we can compare that against their facial expression, a lot of different things like that. So then if we flip back over to the DocDB, this is what these records end up looking like. And we just go through and we insert this over the entire video. Everything has this video asset ID, and so that's how we recombine all the records later on. And so on the lines of that recombining data, we make use of the stored procedures in DocumentDB. So this lets you write JavaScript side functions or stored procedures on the DocDB itself, and then you can call those through the SDK. So I'm going to show an example. This is one of the stored procedures we have. So this one basically will return the asset ID, which is really just a GUID, based on 2 parameters that you pass in. And so it does that using this chain filter and map. So we're going to say we want to filter documents where the presentation ID is equal to one thing we pass in and the attempt is equal to something else. And then with map, we're going to return just the asset ID. And so then we're able to invoke that from an API app in C# using the SDK for DocumentDB, and that really just looks like this. So we have a method here called runSP, and it returns a task of stored procedure response. We pass in all the parameters that we need, and then really the whole thing is it just calls this execute stored procedure async. It gets the name of the stored procedure and all the parameters, and then it just waits on the wire for us to get a response back. So we were able to use this and actually build a repository pattern where each of the entries in the repository really just mapped the data from the front end to the name of the stored procedure and then called this in the back end. So moving swiftly along, now that we have all of our data in the DocDB and we're able to both call stored procedures to get the data back out so that we can show the front end, the next part is how can we use machine learning and try to get a little bit more information about that video. So the Azure ML Studio is basically an easy way to connect into data sources and practice and experiment and build out a model. And then if you like it, once you've trained it, you can operationalize it as a REST endpoint. So in our case, the first thing we did, and probably session has expired. Yeah, I'm sure this will be fine. So the first thing we did is there's actually a direct connection so that we can connect directly to the DocumentDB. And this lets us pull in our data directly. So once we have it in, the next piece that we do is to join all of those rows back together. So remember, as we're processing, we're just writing out data bits and pieces as we're getting it and generating it. So we actually go back to this stored procedure where we start to collapse the data back down so we can get back to row data. So once we have that, let's try logging in one more time. Azure ML Studio. I don't know why it kicked me out. But once we've joined the data back into row, then we can use custom R scripts that we wrote, and we can execute those against the data set. And those basically just pull out certain features that we care about. So if we wanted to build a model like we do, where we want to cluster around certain features to say what video is expressed, whatever the company cares about. So say we want topic detection. So we want to cluster around topic detection. And then once we have that cluster, we want the videos that covered the most topics. That's going to be our best set. So that's going to be the top values. And it looks like it's given up, but that doesn't matter. So the point is, once we have that cluster, we can actually build a second model, which is a predictive model based off that cluster. So we can say, once we reach this critical mass of maybe 20 or 30 videos, we cluster around the features we care about. So were they positive? Did they hit all the topics? Then we can build a build a predictive model so that new videos after those 20 initial seed ones, then we can just start auto-scoring videos. Because we know we've already clustered, so we know a way we can compare those videos against our existing set, and then we can just start auto-scoring. So we can actually go from a batch processing to this operationalized REST endpoint once we hit that critical mass, which so far for us has been around 30 videos. And it looks like it still doesn't want to let me log in. But you saw basically the tree. There's really not that many steps. There's a clustering algorithm that's already set up. I think it's k-means that it lets you use out of the box in ML Studio. We actually used our own, which you can import zip files into the model, and then you can reference those zip files. So we pulled in a bunch of R that had the clustering we wanted to use, and then we can call that right from inside our own model. And so that's it. I'll turn it. Michael will take it back over here.
All right. All right. So I promise Azure is not down. So back to the, yeah. So we did the code deep dive. So we're so excited that during the keynote this morning that Microsoft is still showing its commitment to AI and cognitive services. We have a lot more to do in this space. We look forward to augmenting our product even more as Microsoft comes out with new cognitive services and AI capabilities. We will absolutely be integrating that into our application. Check us out on Twitter at Brainshark Labs. If you're into this kind of stuff at all, please contact us via email. We love to collaborate with other like-minded people who are looking to explore the boundaries between human and machine. And if you want to see more, if we want to show you the demo, please find us afterwards. We'd be happy to show you. Great. Any questions? So the question was, are we measuring facial emotion while in the simulator, or is it separate? So today we're not doing it in the simulator because it wasn't real time enough, but I think we all heard during the keynote that that might have just changed, right? That cool workplace safety thing may show that that is now possible, and absolutely as soon as we get back to the hotel, we're gonna go check that out. Anyone else?
That's it.
All right, good, we're out of time, thank you.
Thanks.